right, for this next example, um, they want you to write an equation for the phi of the object. Now, recalling this little formula here is important because we're going to plug in the values for v and s into the formula so we can write the equation. Now, since the object is directly upward at 64 feet per second from a platform that's 80 feet high. So hopefully you recognize that the 64 feet per second, that's our v, which is our velocity, and 80 feet high, that's our s, our starting height. Okay. So now we have our values that we're going to plug in. And our equation here would be h of t equals negative 16t squared plus 64t plus 80. All right, so now they want you to use this equation to answer the remaining questions. They want to find the maximum height. Now, in order to do that, we're going to have to use our calculator. We have to go in. Let me clear this one out. I'll clear that second one out too. We're putting in our equation, negative 16x squared plus 64x plus 80. And we're going to hit graph. And like this graph that I'm showing right now is by a previous window. And so this, I have a lot of wasted space here. And if I look at my tick marks, 1, 2, 3, 4, 5, 6, okay. So when I go to my window, I don't need to go to 15 seconds. 6 seconds looks like it's enough. And I don't need to start at a max of 1300. Let's start at 100 and see if that's enough, because we're starting at 80. So 100 is not enough. So let's try, oops, the scale is still 1, sorry. Let's try 150. There we go, okay. So now I can use this window to get to my answer. So the maximum height means I'm trying to find the max, so I can do second trace and do 4 for max. And it says left bound, but my cursor is on the right, so I have to arrow to the left side of the curve. We just want to be left of the vertex, where I think the vertex is. So that's about right there. Enter. Right bound, right of the vertex, enter, and then enter again. So this comes out to be 2 seconds, all right? And I see at 2 seconds, it takes 2 seconds to get the maximum height of 144. So now I can put that into this worksheet here. Find when, so when is the time, so that was 2 seconds. Find the max height, that height, and the h of 2, that height is 144 feet. All right, now it says find the height of the object after 3.5 seconds. Okay, so there's after 3.4 seconds, this is my t. So I could plug in the 3.5 into the formula. So negative 16, 3.5 squared plus 64 parentheses 3.5 plus 80. So I can go to my calculator, just to my blank screen here, and type it in that way using the parentheses. Or because I have it graphed, I can go to second trace and use the value key. So, excuse me. So now we're trying to find the value on the graph when the x is 3.5. So I'm just typing in 3.5, and we see it's 108. Okay. So our answer here is 108 feet. Kind of ran out of room. Now, the question here is, how long after the object is launched will it take for the object to hit the ground? So when it hits the ground, that is our 0, or our x-intercept. So I'm checking for how long it takes to get to 0. So to do that, I want to put in 0 for y2, Then do second trace, 5, and enter 3 times. And it takes 5 seconds for the object to get to the ground. All right, so T is 5. Now this last part here, they want us to write a realistic domain. Since our domain is our x values, well, that would be, we want basically from when it starts, the initial starting part time, to when it hits the ground. So that's 0 to 5 seconds right here, 0 to 5. And then our range, the max it got was 144. So 0 to 144. All right, now let's look at the next page real quick. So this is a recap of everything we're doing here. A cannonball is shot up in the air from the side of a mountain. It shows us that the flight of the cannonball can be modeled using our vertical motion, which is what we're using the projectile motion here. So we're using the same formula. Nothing's changed. And it tells us that h is the height of light, t is time in seconds, v initial velocity, and s is the height of the cannon above the valley. So they want us on here is to first write an equation for that flight of the cannon. If it is 704 feet per second would be our velocity, and 200 feet above the ground. That's our starting height. So h of t would equal a negative 16 t squared plus 704 t plus 200. This is find when the cannonball reached a maximum height. All right, so let's put this equation into our calculator, and I'm going to talk about some other problem solving tools you have on your calculator. So I need to do plus 704x and then plus 200. And right now off the graph, I know it's not going to hit because our graph had a max of 150 and we're already talking about starting at 200. So when we first were learning how to get our window, hold on. Okay, sorry about that. So what we could do, I was trying to review a feature we did before to help us see the graph, and that's if you're not too sure of how to change your window, to help you out, you can hit zoom, and then if you pick on yours, you might not see number 9, but if I continue down, zoom fit, so I can just hit enter there, or I can just hit number 0. So like on your calculator at your desk, you can just hit zoom and then 0, and it will fit part of the graph, so you can get an idea of its picture, of its shape. So like right now, I can see it, but I don't see the full parabola shape. But if I look at my window now, they've already kind of put some values in here. So like if I increase, let's say if I make it to a max of 10, okay, it's still going up. So that lets me know I need this value to go up as well. So maybe I'll go to 4,000. And then let's see, well, it's still going. Okay, we're talking about a cannon, so that makes sense. Change it to 10. All right, so now we're starting to see where it's going to come down. All right, so let me get 20. Why is it not? Okay, hold on. All right. I need more time in my window as well. 30. There we go. Now we're starting to see the shape. Now, let's go to our questions here. Let's see, do I need when the camera reaches the maximum height? Find the maximum height. Find the height after 4 seconds. After how long is the camera for? Will it take the camera? Okay, so we do need to see when it hits the ground. So I'm going to open up I think for our time here, I'm at 30. Let's make that 50 seconds. There we go. Now I can see the whole shape here. I probably don't need, I could maybe take away some of this dead space here. But let's just start right there. I can at least get my max and my 0 here. So here, the first question we need to address together is find when the cannonball reaches the max height. So because we're talking about when, we're talking about the time here. Okay, but for a maximum height, I can use my calculator and do second trace for max, but make sure the cursor is on the left side of the curve. I'll come back right there, or left of the vertex, and then right of the vertex, and we get a maximum height. We need the time though, so it takes about 22 seconds. Think about it, because if I round here, this is going to be rounding up. So my time is 22 seconds here. And it says find the maximum height. Well, the height, the h of 22, the height at 22 seconds is, I think it was 7,944. It's a big thing right here. 44 feet. Okay. All right, now they want us to find the height of the cannon after 4 seconds. So after 4 seconds, this is time. So this is when t equals 4, okay, or x equals 4. So the new trick I would kind of refer to is when you do second trace, do your value 1 of x of 4 seconds, and then we get a height of 2760. All right. So at h of 4, it's 2760. Okay. Then we want to know how long after the cannon is fired will it take the cannon to hit the ground. So hitting the ground is our x-intercept, or another word for that is our 0. So this is when I want to put y equals 0 for the second equation right here. And then look at our graph, and we want to go second trace, 5 intersect, and enter 3 times. And it takes 44.28. Yeah. So how long? 44.28 seconds. Okay. And then they want us to come up with a realistic domain and range. Think of the highest and lowest values. So our domain, and I'm just going to abbreviate, would be, I'm just going to do bracket notation, 0 to the 44.28, and the range would be, 0 to 7944. All right, so that takes care of that example, or that practice problem. And now we're going to see, kind of lessen the guidance as much on our next cannon problem. Let's see how well you do on this. All right, thanks.